Okay, hello everyone. This is additional video on how to work the related rates that I have been given this problem in class. This number here, so number 13, 14, 15, and 48, 49, and 50. So let's start with number 13. Okay, so I hope you can try by yourself first, and then we can solve it together. Okay, so try first. Okay, I will give you some time. Okay, you can pause the video and then start to work on this number 13. Okay, now let me work this by taking some information from the question. So first is altitude means height. Okay, we have height 1 miles and a speed 500 miles per hour horizontally. Okay, so a plane flying horizontally. So maybe imagine a plane. Let's say that's our plane. It's going to be flying horizontally like that. Okay, and it has an altitude of 1 miles. Let me use different color. This is 1 mile, and then it flies 500 miles per hour, passing over the radar station. Let's say this is the radar station. Oh, okay, that's the radar station. And then find the rate at which the distance from the plane to the station is increasing when the plane is 2 miles away from the station. Now we need to simplify this question. Okay, so first is let's name all these terms. Okay, so the plane will move, right? And 2 miles is when the plane move here, and this will be 2 miles. Okay, so let me erase that for a while. But since this is the variable that will change over time, we can write this as, let's say, x. Okay, and then we need something to connect this x with the height or the altitude. So I think the best way, the simple way, is just to make it a triangle, and then make this triangle the Pythagorean, the hypotenuse will be y. Okay, let's say just name. Okay, you can name with other variable as well. You can name is a, b, okay, any variable. This is just a name. Okay, and then other 500, this is 500, dx dt is 500 miles per hour. Okay, so it's the plane is moving. Okay, and when the plane is moved, the variable x will change, variable y will change. Okay, we can think the plane, for example, if the plane here, then this will be y, this will be x. Okay, so x and y can be in any point, okay, according to this triangle. Now we need to develop our solutions or our relations with the Pythagorean formula. Okay, so we can write that this y squared is equal x squared plus this 1, right? 1 squared. Okay, but by writing this, and then if we let this we can take the relation and take derivative, then we can get the rate. Okay, so what is the questions actually? So this is a little bit tricky. But somehow, without knowing the exact purpose, sometimes you can guess which one is the question is. So we have this, right? We have this relation of the Pythagorean. We have this information about 500 miles per hour. What else do we need? The only thing that we can find is this. And I think this is the question, okay? So the rate at which the distance from the plane to the station is increasing, which means it's asking when the plane is moved, there will be some changing based on how far the plane with the station, okay? And it is best to describe with this y, okay? Y can be there, y can be here, right? Or there, right? And the question wants to know what is the rate, okay? What is the rate of this y? The y change, which means dy dt. So let me just undo everything here, and then we can focus on this derivative. So we're getting 2y dy dt, 2x dx dt, and then 0, right? So 2y is, so the question is when x is equal to or what's the question is when the plane is 2 miles away. So 2 miles away, 2 miles away means y, okay? So when y is 2 miles away from the station, this one here, then since y squared is x squared plus 1, then x squared is 4 minus 1 or 3. So x should be square root of 3. It should be positive, okay? In this case, to make it will be unreasonable if it is negative, right? So we take x equals square root of 3, then dy dt. When y equal 2, this is 4, this is 2 square root of 3, dx dt is 500. So we can take this is 2, take that, 250. So we get dy dt is 250 square root of 3 miles per hour. Okay, I think that's the answer. Okay, that's number 13. Okay, now number 14. We have a snowball that melts and the surface area will be decreasing at a rate of 1 centimeter square per minute. Find the rate at which the diameter decreases when the diameter is 10 centimeter. So perhaps we need to describe this in let's say that's our snowball, and then let's maybe describing the diameter. Okay, so the diameter will change because the snowball is melting, right? So I think let me write giving this to make it a three-dimensional perspectives. So let's say this is the r, this is the, let's say, variable x. Okay, now we know that the surface area decrease. Okay, we know this surface, let's say its surface area is s, this is decreasing at the rate. I will define decrease as minus, okay, just to make it easy for us to understand that the expectations from the calculation will be reducing the number, right? So we need to find what we need to find rate at which diameter decrease. Need to find diameter is x. If diameter is x, then we need to find the x dt. When x is 10 centimeter. Now, the surface area, I hope you know the formula. This is 4 pi r squared. Okay, since it's r, I think I will change the x to r. Okay, so x is 2r, so r, or we can rewrite this r as half x. Okay, so s 4 pi and a half x squared. So this will cancel, and then pi x squared. Okay, this is s. Now if we take this derivative with respect to t, this will give you the s dt pi, or it become 2 pi x dx dt. And then when x is 10, right? When x is 10, so when x is 10, now dx dt becomes -1, 2 pi, 10, or we can write here dx dt then becomes 1 over, or -1 over 20 pi centimeter per minute. So this negative means that the rate of decrease. Okay, so this is the answer. Okay, now another question. A street light is mounted at the top of a 15 feet tall pole, and a man 6 feet tall walks away from the pole with some certain of speed, 5 feet per second, a long straight path. How fast is the tip of his shadow moving when he is 40 feet from the pole? So it's kind of interesting. If you are not really understand what it means, we can start by take some diagram. So a street light means it has a lamp, right? A lamp on the top. Okay, so let's say we have here, okay, this is the street light. So let me draw its street light. And this will be 15 feet. Okay, and then a man walks away from the pole. Okay, walks away. So let's say the man will walk maybe here. He's walking. Okay, and then let's draw the ground. So this is the ground. The man is 6 feet. Maybe draw here. So 6 feet. Let's make sure that we draw. This is 6 feet. Okay. Now the light. Imagine the light. The light will disperse to everywhere, right? Diverge to everywhere. But somehow, if we are remembering the physics, then we are able to see that the light will somehow cast a shadow, okay, through this person. So this part right here is the shadow, right? It's the shadow. In other words, we can draw a simple triangle. Okay, maybe that's bad. Let me make it another one. Why it's not? Okay, now that's my triangle. Okay, and then add another one. So this will be 15. This will be 6. Or maybe let me just write the number. Okay, this 15 and 6. Okay, and then what else? It walks away from the pole with the speed of something, a long straight path. How fast is the tip of his shadow moving? Okay, so the question is, what is the tip of the shadow? So let's write and let's define this line as x and this is as y. Okay, so the man is moving from the nearby the pole or from the pole to the right side, right? So we are actually want to find out, so need to find dx plus y dt. Okay, it's a little bit interesting here. So tip of the shadow is this part here. So of course we are going to include all the distance from here, right? Okay, let's start to do that. Okay, now how fast is the tip of his shadow when he is 40 feet from the pole? So when x is 40, then what is this, right? So that's the question. So then we are going to, yeah, we need to write down the formulations that can relate everything. Okay, I think we can start with this triangle. So this triangle, if you remember the I think in junior high or high school you have the ratio in between triangles. So 15 over 6 is equal x plus y over y. Is that correct? Or maybe better if I write 15 over x plus y over 6 over y. Okay, we can divide by 3, 5, and then what else? We have 5y, 2x plus 2y, and then we can make 3y is 2x. So y is 2 over 3x. So I will change all y into x. Okay, so the x plus y dt. Okay, this actually d dt of x plus 2 over 3x, or in our case this will be 5 over 3x, or we can say this is 5 over 3 dx dt. Our dx dt is 40, So it will be 200 over 3 meter per second, or not meter per second, what is this? Feet, right? Feet per second. Oh, wait. This is wrong. dx/dt is 5. So this is 5. So 25 over 3 feet per second. Okay, though the 40 feet is not really important now, right? Okay, we solve this. Okay, another one. Okay, you can see all this question first, and we can have our answers if you try first. Okay, so pause the video and try. Okay. All right, now the question about Ferris wheel. So a Ferris wheel with a radius of 10 meters is rotating at the rate of 1 revolution every 2 minutes. How fast is a rider rising when his seat is 60 meters above the ground level? Okay, so Ferris wheel, I hope everyone familiar with this. So Ferris wheel is something that you are usually find in the amusement park. So I say this is the Ferris wheel. So of course Ferris wheel having a cart like this. Okay. Oh. Okay. And then it will rotate. Okay. Okay. So let's say this is you. Okay, this is you. So we have someone here. Okay. And then with a radius 10 meters, so I think we can draw that as well. So radius, and then what else? We have height, right? We have height. So this 10, and this is also 10, right? This is also 10, same radius, so also 10. So the total height, okay, is from this cart. This will be 16 meters, right, above the ground level. This is the question when we are asked about this, right? 16. Or we could say maybe later I will write the 16, but this is just for illustrate how is our diagram. So let's say we have here we have the height. Okay, so we have the height, let's say h, and then we have, this is radius, but for up until here we have x. Okay, now let me redraw that, okay, in more simple. So we can have, so this is height, this is 10, this is 10, this is x. Okay, and then it's rotating. Remember, every rotations, then I think it's better to include theta over there, right? So 1 revolution, what is 1 revolution? 1 revolution. 1 revolution is 2 pi radian for every 2 minutes. So this is 1 revolution. So this is the rate. So what is the rate? This is the angle. So the angle is 2 pi radian divided by 2 minutes. So it becomes pi radian per minute. Okay, that's how one revolution means, okay, for every 2 minutes. So we have this, okay, as our rate for the rotation. And then it's asking how fast is a rider rising when his seat is 60 meters above ground level. So it's asking, actually what the question is asking is how fast from this, maybe let me write with, okay, so from here, remember that it has some height, okay, it has some height. So suppose that we have moving to here, the height is changed, right? So the question is wants to know how fast the rider changed the height, okay, which means the question is asking about dh over dt. So need to know dh over dt, okay. So when the seat is 60 meters above the ground, when this is 16, then h is 6, right? So we have 10, we have 6. I think not good, should be okay. Okay, I think this should be okay. And then this one will be 8, right, by Pythagorean. So when h is 6, then x is 8, okay. And then we know that from the angle we can take sine theta is h over 10, cosine theta is 8 over 10, or perhaps this is 6 over 10, 8 over 10. And then from the relations from the variable as well, this is when h6, x8, then we have these two sine and cosine. But the total relations based on the triangle, okay, based on the triangle is sine theta, the variable is h, and divided by 10. Okay, so we take this, derive, this will be cosine theta d theta dt equal dh dt. Okay, now dh dt is equal 8 over 10 multiply with d theta, dt is pi, so pi, and 1 over 10 I will multiply to the left is 10, so dh dt is 8 pi meter per minute. So that's the answer. Okay. All right, we have number 49 now. A plane flying with a constant speed, it passing over a radar station at altitude 1 kilometer and climbs at an angle of 30 degrees. At what rate is the distance from the plane to the radar station increasing a minute later? Okay, this is quite interesting. So let's say we are let's draw a plane. A plane. Okay, flying and pass over ground radar. Okay, this is, let's say this is the 1 kilometer height. So this is the radar station. That's the radar, right? Radar station. Okay. Okay, climbs at angle 30 degrees. So from this, it's take another climb. So let's say this is 30 degree. Okay. At what rate does distance from the plane to the radar increase? So it's actually it asking this distance here, right? Okay. Now let's name our variable. So let's say this is x. You can name a, b, anything, okay, but I will just stay with x, and this is y. Okay, now we have this triangle, but it's not a right triangle, right? It's have I don't think we can relate with the Pythagorean, right? But we have three sides and an angle here. Now this become 30 plus 90, it's become 120. So let's say this is y, x, and 1. Okay. So we need to use, I hope you also remember, law of cosine, which stated that y squared equal x squared plus 1 squared minus 2, 1, x, and then cosine of 120 degree. So this equal x squared plus 1 minus 2x, and then cos 120 is negative 1 over 2. So this will be what? Plus x, right? So x squared plus x plus 1 equal y squared. Okay. So we would like to know the dy dt, of course, right? This is the question. So take derivative with respect to dt. And let's just write first what kind of formula we get from this. So we get dy dt is, this is 2x plus 1 dx dt over 2y, right? Okay. Okay, dx dt we know. Then we need to find dx dt. I mean dx dt we know. We need to find x and y, right? Okay, we have this, right? So we have dx dt is 300 kilometer per hour. So after 1 minute, so we can imagine that the hour, 1 hour is 60, right? So after 1 minute, x is 300 divided by 60. It's 5 kilometer. So 5 kilometer is for 1 minute. For 60 minutes, it's 300, right? Okay. And then when x is 5, then from the law of cosine, we get y is square root of, we input this 5 into this. Okay. So this will be 25 plus 1, or 25 plus 5 plus 1. So it will be what? Square root of 31. Okay, let's just write 31 like that, kilometer. So xy we get, then we take this. So dy dt is equal 2, 5, it's 10, so 11 over 2 square root of 31 multiply with 300. So this will be 150, 150 and 11. 5, 5, 1, so 6, 165, 165 over kilometer per hour. Okay, that done. Not really good number, but this is our answers. Okay, now we have number 50. Two people start from the same point. One walks east and the other walks northeast. How fast is the distance between the people change? Okay, so this basically from one point here, so let's put it's point A. So from this point, one person going east. Okay, so let's write that we have the x dt. Okay, this is x, 3 miles per hour, and we have northeast, let's say over there. And again, I will keeping old style x and y as a name, but you can choose another name if you want. So let's say y, we have dy dt is 3 miles per hour. So this is northeast, this is east. Okay. So the question asking how fast is the distance between the people change? The distance between these people, of course, this distance here, right? And we can name z. Okay. So we would like to know the z dt. Okay, now how do we relate all of this? Okay. We have x, y, and then we want to know z. We have dx dt, we have dy dt. What else do we have here? One is east, the other is northeast. And remember in the traditional maps, if you are remember in your maybe from your elementary school, we know that the angle between all of this became 45, right? Okay, all this, right? So we know that this will be 45. Okay, so based on this 45 degree, I think similar to what we have in this triangle here before the previous question, then we can try to take the law of cosine. Okay, so z squared equal x squared plus y squared minus 2xy cosine 45 degree. Okay, now I think we can write this as x squared plus y squared minus the cos 45 is half square root of 2, so we can cancel this 2, right, with this one. So we have square root of 2 xy. Okay, yeah, we get. And then next one will be take derivative with respect to t. This will be that, and then this is 2x dx dt, and then plus 2y dy dt, and then negative. Okay, remember, careful here, we need to take the product rule. So y plus x dy dt. Oh, no, because it's respect to t. I mess up, sorry, I mess up. So we have to have x dy dt, and then y dx dt. Okay, so we have all these components, and then what's next is 15 minutes, right? So 15 minutes mean, 1/4 hour, right? 1/4 hour. So 1 hour is 3 miles. So 1/4 will be 3/4. So x is 3/4 miles, and y is oh, this is 2. Sorry. Okay, this is 2. So y will be 2/4, which is half miles. Okay, so far so good. So okay, I think we've done. Okay, next is finding z. Z is square root of 3/4 squared plus 1/2 squared minus xy. Xy is 3 and 8. Wow. I think let me rearrange this so that we can have in one screen. Okay, so z is, so this will be 9/16 plus 1/4. Wow, this is interesting. I think maybe just taking the z squared first. Okay, let's see what this looks like. So 9/16 plus, this is 1/4, but I would like to write in 4/16 minus, this is 6/16. So 9 plus 4 is 13. So 1/16, this is 13 minus square root of 2. That's the z squared. But then we are going to have z. So z is square root of that. A really bad number, but I think we don't really have much choices. But the idea here is we are going to evaluate dz dt. So taking z is this, okay, dx dt is that, dy dt is this, and yx is this. Okay, I hope you can just plug in by yourself. I think it's okay to use calculator for this one. This is not really helping the questions, and the answer also complicated, but we got the idea, right? We got the idea. Okay.